So let us redraw the molecule on this page. So far we know 4 reactions. So 4 tools is what we know: SN2, SN1, E1 and E2. Can you identify a bond in the target molecule that can be made using the reactions that we have learned in this chapter, which are these? So if you uh, think about it, then you will realize that the double bond over here could be created by doing E1 or E2 reactions on alkyl halides or some other substrates that we talked about at the in section 7.12. Next, draw the substrate and the reagent. Let's change this to reagent necessary for the reaction to make this product. So we are going to draw the product here, and we are going to draw the structure of this substrate here, maybe in this box, and the reagent over here. So notice that the double bond is being generated between these two carbon atoms. Now remember, for E1 and E2 reactions that create double bonds, so there should be bond here. So that create double bonds, we need a substrate which has a leaving group and a base. So our reagent is basically a base, and a substrate could be an alkyl halide. And also remember that we can use different types of bases to induce the elimination reaction. We want to prefer E2 and not E1, and the reason is because E1 never occurs alone. There is always an SN1 product with it. So that is the reason we want to prefer an E2 mechanism. So we want to use a strong base. So this should be a strong base, so we get an E2 mechanism in the reaction. These substrates are alkyl halides, so the double bond is being created between these two carbon atoms. So the leaving group should be on one of those carbon atoms. So the substrate could be this, or it could be this. And a base for an E2 elimination could be sodium hydride. Remember that chart that we need to memorize. The first column on that chart is base only reagents, and those are these ones: sodium hydride or DBU or DBN. Any of these could be used, and between these two substrates, one substrate is better than the other, and we will talk about that in just a second. So what we have done here is that we have thought backwards, that how this double bond could be created, and we thought about E2 reactions and the substrates that are needed for E2 reactions. So often when we talk about retrosynthetic analysis, when we think backwards, we actually draw the product on the left hand side of the equation. So for example, we will draw a product on the left hand side, and we will use this type of arrow, which basically means backwards, and we write the substrate and the reagent. So for example, the substrate could be this or this, and the reagents could be sodium hydride or DBU or DBN, any of these. So let us verify that these substrates and reagents will work, and that is the step 3 of retrosynthetic analysis. So we propose two substrates. One is this and the other is this. Okay, let us treat the first with a strong base, and I'm just going to choose DBN for that. And when we do this, notice that there are two beta carbons, but these two hydrogens are equivalent because the molecule is symmetrical. So no matter which hydrogen is abstracted, we will get one single product which looks like this, which is our product. However, when we treat this second reagent that we propose with DBN, we will get two products because the two beta hydrogens are different in this case. So both of these could be eliminated to form this product plus the product that we want to build. So we are interested in this product, and so the top reaction, which gives only the desired product, is going to be the preferred pathway to make the uh, molecule that we want. The second substrate is not so good because it will result into mixture of two products. So this is the verification that the reaction will work, and then one last time we could draw the reaction in the forward direction and propose a synthesis. So basically, retrosynthetic analysis is used to propose synthesis for a molecule. How do we build a molecule? So we think backwards. This concludes chapter 7, and we will do more problems on retrosynthetic analysis in class.